This is a story about God playing dice with the universe, something Albert Einstein told us he didn't do back in 1926. Einstein was criticizing physicists' theory of quantum mechanics. Yet, a century after Einstein's denial, billions of dollars are being invested today in taking that theory and turning it into reality, with the prospect of a revolution in computing potentially larger even than generative AI.
Quantum computing is very high potential.
Investors are increasingly asking us about the implications of quantum computing.
Quantum computing.
Quantum computing.
Political and state level economic support to develop quantum, and we want to be part of that.
IBM is one of the companies leading the charge in quantum computing.
At IBM, we developed some of the very foundations of quantum information science, starting as early as 1970.
Jamie Garcia is the director of quantum partnerships at IBM. A PhD chemist, she's working on quantum computers
but doing useful quantum advantage examples for our customers and embedding ourselves into their workflows on an ongoing basis.
So what will it look like as we go beyond showing so-called quantum advantage in the lab and embedding it into real-world workflows? One place people look to first is in the life sciences, work like Dr. Garcia is doing at the Cleveland Clinic.
An example of something that we've done is we've taken some of the algorithms that we've worked on for chemistry, and alongside Cleveland Clinic, we've started looking at different chemical processes that they really care about. So you can think about this in the larger context of, therapeutics, design, drug discovery, that kind of thing. And really what we're doing with Cleveland Clinic is pushing the boundaries of algorithm development, methodology, of using quantum computers, again, in concert with classical computers to come up with solutions to problems that they care about. Protein folding is definitely one area, mRNA, secondary structure understanding, how things come together and how they look in sort of 3D is a very interesting area, as you can imagine, as you're trying to understand how these things fit together in a biological system.
But figuring out who's ahead in this race sometimes feels like predicting those dice. IBM says it's ahead because it has more total qubits in its machines. IonQ says it's not the number of qubits, but the number of algorithmic qubits, putting it in front. And quantum company Quantinuum has yet a third measure of quantum volume. Maybe we shouldn't be surprised that there isn't a single measurement. It's like those qubits that are both ones and zeros at the same time, until they're observed. And it looks likely that we will all be able to observe what quantum computing can do for us in the very near future.